Alright, we're back, and today we're going to be working on our interpreted language called valor-lang. So, I'm just in Helix right now, but let's see, let's go ahead and open our, let's go to our Lexer, and just go to Lexer Go and see what we have here. So we have package Lexer, type Lexer struct. So this is saying for an input we're going to get a string to go through, and then for each there's a position, there's a read position and a regular position, and then there's a char that we're looking at. In this case it's just a byte type. Position and read position are indices, I think, and then we have a constructor. Okay, input string Lexer. So, okay, I can kind of see what's going on. So we get an input, we get a Lexer, and then return L. So we're returning the pointer to the Lexer. Okay, so they have this func, which doesn't have a name. Wait, what is this? I'm new to this kind of syntax. This is a read char. Oh, it's a method. Okay, I get it. So instead of self, they literally have just like a argument list for it, which is interesting. I've never seen that. Okay. Really weird. Go is probably like the weirdest, like the language with the weirdest syntax I've ever came across, but it's a really nice language to use as well. Okay. So this is a method. So if read position is greater than or equal to length of the input, we're basically restarting, we're resetting, or no, we're returning, hold on. No, we're just setting the present char. So the char is just what the read position is. Okay. So CH, that's the current char, the current character the Lexer is going over. And then, okay, so L position equals L dot read position plus equals 1. Okay. So this is like, the position is the previous position. The read position is just the next position. But if it's greater than or equal to length, you set the char to 0. And we only care about the read position. Okay. There's no way to reset. If ch is 0, then that's the end of the file essentially. If ch is 0, okay. Okay, let's see what else we have to add. I'm reading this Ball Thornston. Is that his name? Yeah, Thornston Ball. Thornston, not Thornston, it's Thorsten. So this person made a book for creating an interpreter in Go, and that's what I'm reading right now. It's pretty interesting. I'm going to read a little bit of it in this video, and we're going to add some stuff to our code base. So this is what we just looked at. Let's review what it is. So most of the fields in Lexer are pretty self-explanatory. The ones that might cause some confusion right now are position and read position. Both will be used to access characters in input by using them as an index. For example, L.input, L.read position, the reason for these two pointers pointing into our input string is the fact that we need to be able to peek further into the input and look after the current character to see what comes next. Read position always reads to the next character in the input. Position points to the character in the input that corresponds to the ch byte. The first helper method called readChar should make the usage of these fields easier to understand. Yeah, so the purpose of readChar is to give us the next character and advance our position in the input string. The first thing it does is to check whether we've reached the end of the input and can't read any more characters. If that's the case, it sets else.ch to 0, which is the ASCII code for the null character, and signifies either we haven't read anything yet or end of file for us. But if we haven't reached the end of input yet, it sets l.cha to the next character by accessing, yeah. And I didn't know you could do this with strings, but yeah, you can just, I mean, given that Go focuses on simplicity, that makes sense, right? After the L position is updated to the just used .l read position, the L and L read position is incremented by 1. That way, L.read position always points to the next position where we're going to read from next, and L.position always points to the position where we read last. Or we last read. This will come in handy soon enough. While talking about read charts, it's worth pointing out that the Lexer only supports ASCII characters instead of the full Unicode range. Why? Because this lets us keep things simple and concentrate on the essential parts of our interpreter. In order to fully support Unicode and UTF-8 characters, since they could be multiple bytes wide now, using L.input, L.read position wouldn't work anymore. And then we'd also need to change a few other methods and functions we'll see later on. So it's left as an exercise to the reader to fully support Unicode and emojis in Monkey. So Monkey is just the language they're creating in the book. Let's use rechar in our new function, and so our pointer Lex is fully working in a fully working state before anyone calls .next token. Our tests now tell us that calling new input doesn't result in problems anymore, but the next token method is still missing. Let's fix that by adding a first version. So it's another method, and this is in the same file, right? So we're going to, we already import, right? Do we need to import, really? Import valor-lang token. I think I can do that, right? Imported and not used. Okay, that's fine. How do I go to like the end of the file? I mean, I can do that. It's like, why? Some of the Vim key bindings have changed with Helix after installing Helix, but it's fine. Okay. Next token. So we're returning a token type. Var token. So we're going to use a switch statement here. I haven't used that in Go yet. I assume it's pretty straightforward, just like the other languages. I really like when languages don't use parentheses, or at least don't require them. That's nice. It makes it easier to look at, honestly. Is it really style? Is it the style for Go to do this? Like, that looks so ugly. This is style guide I was looking at earlier. I think it's down here. Style guide. I want to see what the style guide is for. Whatever. We'll worry about that later. Let's just focus on our code here. So yeah, we got a switch. I guess I'm just gonna do that. I'll just put cases in weird spots. Okay, new token, token.assign. It'd be nice if I could get some like Copilot in here, but I don't know how to do that. It's fine. We can obviously just copy this too, which I should just do. I understand what's going on. So case 0, case when the char is 0. Literal is nothing, and the type is EOF. Interesting. I wonder why we don't just do the same thing. Like, didn't we just, let's see, if I go and open, let's see what this looks like. Don't we have like an EOF? But it equals EOF, okay, it's weird. So it's empty. So yeah, let's go ahead and get this done. I wonder how I can just like move this, all this stuff. Can I do that? I can't just like indent. Let's see, how do I indent? Oh, okay. Let's see. That works perfectly. Let's go. I want to know how to make multiple cursors actually. Shift C. Okay, let's try it here. So Shift C. Oh, that's awesome. But how do I go out of that? So comma, and then if we were to select all of these and do Shift C, no. Oh, that's so cool. And comma, okay. Okay, so we have some errors here. Firstly, let me make sure this is right. I see what went wrong looking at this now. There we go. Okay. So we got semicolon, L per paren, R paren, comma plus L brace, R brace. Yeah, everything looks good. We have a bunch of errors though. What's wrong? Undeclared name, undefined new token. Okay. Missing return. Okay, yeah, we gotta return something. I'm guessing we just return toke. That would make sense, right? You know, I'm gonna actually have this named. No, that's not what I wanted. Let's get rid of that and use token.token. And then we can really just do return, right? Empty return. And that should work. Token redeclared in this block. Oh yeah, okay, so we can just get rid of this. Wait, what the heck? Oh, I must have went back too much. Oh, what the hell, dude? It's like not saving my shit. Perfect. It's kind of nasty that we do this. I mean, this is somewhat of a long, I don't know. I think it's okay that we can do like a naked return here. It should be okay. But what we need to do is we need to address this undefined token, undeclared name. I'm guessing we're gonna add that, yeah. So we're gonna add some stuff here. It's saying we need to call read char for the next char. This makes sense. Read char, and we return toke, but I'm just gonna naked return. I really like naked returns. They're so simple. It's like if you have one variable that's like the whole point of the method, then it's like you can just use a naked return. It just makes it easier to look at. So let's go ahead and define new token. So new token is a function this time. Token type token dot token type, and then ch, which is just a byte, and then we're going to return token dot token. Token, so we're basically initializing this struct, right? And our input is, or no, we're initializing a token. Our type is token type, and then our literal is a string ch. Okay, well, we're still having issues because we haven't declared the token. Wait, field literal and struct literal. What does that even mean? That's the basic structure of next token method. We'll look at the current character under the examination and return the token depending on which character it is. Before returning the token, we advance our pointers in the input, so when we call our next token again, the that's cha field is already updated. A small function called new token helps us with initializing these tokens. So I'm a bit confused why this isn't working. I guess it has to do with the packaging structure or something. Let's see if we can get this working now. Go test. Selector. I think that's gonna work. Structure type, token type, literal. Yeah, so what's going on here? Oh, I put lowercase literal, that makes sense. There we go. No errors, we're good to go. Run shell command. Go test. Lexer. Job failed. Why? So go test Lexer. Let's try that. Package Lexer is not in std. I need to put dot. Let's try it. Failed. Ooh, okay, what did we do wrong? So open. Let's go to tests. So yeah, assign, token assign. Everything looks good. Let's make sure we have everything here. So assign, semicolon. Parentheses, okay, that's left paren, comma plus brace, right brace. Yeah. Huh. Expected parentheses got EOF. So, what did we do wrong? Let's go back to our test to make sure it's right. Tests, struct array. Okay. What the heck? Let's make sure we have everything set up. So, this is looking good, yes. Everything looks good, I mean. That's amberwood looks so nice, but it's just too curvy. Dracula. Man, these ones look really nice, but theme. I kind of like this one. Farah. This is GitHub. That's Groovebox. I've used that one before. This one's crazy nice looking. Let's try this one out for a little bit. See what it's like. It's really nice to look at. Like I can just see the depth and stuff. Okay. So what can we do here? I really don't know how we can remedy this. So we have, so what was, the error was, it was go test lecture expected assignment got EOF. Okay. Okay, so why did that happen? Helix open lecture test. Okay. So we should have got the assignment here. Instead we got EOF. The literal is wrong. It's the literal that is wrong. The token type. Wait. Token type? Got assignment. Should have got EOF. Should have got EOF. I got assignment instead. I'm gonna print ln toke. Can I do that? And shell command go test. Okay. Run shell command. I need a dot. What the heck? Okay. Whoa! Why is it bringing this up? Okay, that was weird. I guess I thought it wanted me to open it or something. I don't know. I should have printed something. So what we can do is we can get open. Actually, I want to see our next token again. So we call next token, we chuck char. Wait, have we read anything yet? If we haven't read anything, it's going to be 0, right? If it's 0, it's going to be EOF, and that's why we have a EOF thing, right? We had to call read char first. Is that what it asked us to do? Did I just not put that? And new, did we do that? We did not. Okay, that's our issue. That's really important. Now if we do a go test, we're good. Nice. So it's working now. Great, let's now extend the test case so it starts to resemble monkey source code. Oh wow. Okay, so they're doing a new test. Test new token. Okay. Oh, did they just change the function? I think they did. They just changed it. Oh, they extended it, right? They changed the input. I don't know why we'd need to do that. Shouldn't we just make a new function? How about I just make a new function? Actually, fine. We'll keep things simple. So I'm just gonna copy this. I love how Go handles like multi-line strings as well. Like that's really nice. Now if I paste shift insert, okay. There we go. And I could have used, whoops, I could have used Shift C for this, but yeah, Shift C is awesome. Should really use it more often. Okay, so okay, what is our actual stuff here? Why do we have an extra left brace? I guess I don't need that. So yeah, let 5 equal 5, let 10 equal 10, add. This is just a higher order function, I guess. Or no, it's just function. It's a function called add, and we can call that. It's just the easiest way to write a function, right? You're just doing it locally in the scope. Test result. Yep. Okay. So yeah, we need to add some. We need to add our expected cases, right? So the first token is going to be a let. And I'm just going to copy this, right? Because we know what we're doing. Of course, I'm not going to write that whole thing. But basically what we're doing, we're just adding each of the tokens. If we were to read out this entire string with our elixir, what would the tokens be? And that's just this. So what I'm going to do is I'm going to go here. Delete all of this, right? Make sure we format, and then we can do shift insert. And that'll give us all our stuff. What in the world? Why does it do that? There we go. We need that line. Everything looks good. Save. Indent 5. Wait, no. Okay, good. We're just gonna add that other line, the first line, and we're okay. Token dot let. Most notable, the input in this test case has changed. It looks like a subset of the monkey language. It contains all the symbols we already successfully turned into tokens, but also new things that are now causing our test to fail. Identifiers, keywords, and numbers. Let's start with identifiers and keywords. What our elixir needs to do is recognize whether the current character is a letter, and if so, it needs to read the rest of the identifier / keyword until it encounters a non-letter character. Having read the identifiers / keyword, we can now find out if it is an identifier or a keyword, so we can use the correct token. The first step is to extend our switch statement. So we go in here, we have to add some stuff. So new token, yes. Okay, we have to change our default. So our default case, we haven't actually added that. So in case it's none of these things, right? What we want to do is if is selected ch. So this is just another helper function. Okay, we got everything. Read identifier. So I think we're just going to copy these functions, look over them, and then we're done. Because I'm getting tired. I'm already tired. So let's see, this will be underneath new token, and we're just gonna do shift it not control shift, just shift. Why does it look like that? What in the world? That is not good formatting. Okay, so read char, return inputs. Okay. There we go. So here's our file. So new tokens, just creating a token from the byte. It's just a little helper function. So we can use it to create a token.token struct. We could really have just like done that, but it's just nicer, right? We could have just used this struct initialization syntax. And then we have read identifier, which is a method. You can tell because of the pointer at the front. And then the position equals l.position. Position is just a variable in there, I guess. I don't know why we necessarily need to do that. I don't know about the colon syntax. I've never seen that before. Oh, position keeps track of the initial position, and then it checks it for is letter, l.char, read next char, right? So, and then, okay, I see. So read identifier just reads the entire identifier. Okay. So all keywords are identifiers, but not all identifiers are keywords, I guess. I'm guessing that's how it works. But is letter, it just checks if it's a letter. So if the ASCII code is in between A and Z, or if the ASCII code is in between capital A and capital Z, or if it equals underscore. That's pretty straightforward, yeah. Okay. So yeah, I think we're done. We did a couple things, but let's just make sure, do the tests work now? Did we do that? Yeah, I'm not sure. Okay, well, we'll come back to that. thanks for watching, guys. I'll probably make a couple more videos like this, but yeah.